Can everyone hear me? Just respond on the chat if you can't, and we might get going. All right. Let's see. Let's make sure that everything's working before I begin. All right. I might just start. Okay. So, hi everyone, and welcome to this webinar. My name is Edmund Hugh, one of the technical consultants for A2K Technologies. I'm based in sunny Melbourne, and yeah, we're good to go now. So, just a bit of, I guess, some notes. I just want to make sure that everyone's microphones are set to mute. And if you can, just keep all your questions just till the end. I'd prefer to actually answer these via email. So at the end, I'll also give you my email address if you haven't already seen on the chat there. I've provided it there as well. But I'll make sure that I provide my email at the end for any questions. And also, if there's any requests for the data set that I'm using today, I'm more than happy to provide that as well. Now, there's been a little amendment to this this webinar due to time constraints for myself. I will just leave off the Excel side of things, but that side of it, if you'd like to see that, just shoot me an email, and I can also provide that in an updated version of this data set. Alrighty, so. The purpose of this webinar is, well, its intended audience really is for those of you out there who are, I guess, CAD managers, and you're swimming in a lot of maintenance work with your iAssemblies. This is something that I've been quite, I guess, passionate about since this actually affected me when I was working and using nested iAssemblies. Okay, so we'll soon just cover all of that as we go. All right, so just a little bit about A2K Technologies. So we're a roughly 150 strong across Australia and New Zealand. A2K provides design solutions for design technology solutions for a variety of different industries, basically any industry that has a design office. So we've got not only vendors, we're not only using Autodesk as one of our primary vendors, but we're also supporting 20 other vendors. Okay, so you can all check that out on our website, which is basically up the end of the slide there. Okay, a little bit about myself just quickly. I come from an IT background, information systems, and also manufacturing. So I worked in the power utilities industry for quite some time, and during that period we actually modelled a lot of high voltage, medium voltage power transformers, some of which contained over 20,000 parts. These became a bit of an issue when it came to data management, and so I found myself working with Volt along with Autodesk Inventor, as well as AutoCAD Electrical. And so I've also been a bit of a developer as well in .NET, and making the various programs that we use work together. And so I've just been heavily involved in that. But these days I'm fairly involved in the Inventor side of training, and also I consult as well with any Inventor solutions and Volt solutions as well. All right. So just moving back into the purpose, or I guess the objective of this, why iAssemblies can become an issue. Due to their nature, they're defined by tables. Now, you can appreciate every single table has to have every single row or configuration explicitly set up. Okay, so this can take time to set up each of your iAssemblies. They also take a lot of time to manage. This is because every time you create an iAssembly, that iAssembly points to a number of child parts or child subassemblies. So we have to generate parts each time. This can become too restrictive when each change that you do subsequently to update these iAssemblies can take a bit of time to regenerate these child files, especially when you have nested iAssemblies within iAssemblies and so forth. So this becomes, again, too resource heavy. Your references can also go missing, and these files can end up taking a lot of space. So your portability of these files become quite restrictive as well. So we can end up with also an issue where you end up with iAssemblies within iAssemblies. I call these nested iAssemblies. And what that results in is you have each of these iAssemblies has a table, and so the number of rows multiplies with the next number of rows, and so you end up with n-tier tables, which can equate to exponential components each tier you go up in your iAssemblies. So this can, if you've got 100 members in one iAssembly and you place that into another iAssembly made up of 5, you can end up with 500 configurations. Okay, and then if you place that into another iAssembly, you can end up with thousands quite quickly. And so to manage all of that, it becomes quite I guess painful time-wise. So we need to actually do something about this, and luckily we have a solution in iLogic. And so for those of you who are not aware of iLogic, iLogic is a programming interface. It's an integrated developers environment, so an IDE they call these. And so that allows us to access the variables within Inventor, or the API, the application programming interface. So this can allow us to make changes directly to parts. So this whole iAssembly issue, it can end up with creating a snowballing effect for the poor CAD manager. Okay, so we need to look at reasons why iLogic is a better solution. Okay, so first of all, it's one smart assembly. Okay, it can be, we use the same parts, we only have the one assembly, and there is no need to generate these child files, because we can immediately change each parameter directly from the assembly level if we want. So this enables some fast or real-time changes. We can also, because of this, we can also have quick rework. Okay, and it caters for non-standard results. So things like, if you have a table-driven iAssembly, you're actually having to explicitly define each configuration. So if you go outside the bounds of that, you'll have to actually regenerate all of the parts and all the results. Whereas in an iLogic part or iLogic assembly, we can simply add rules or even provide fuzzy logic bounds, okay, to capture the various possibilities. So instead of creating hundreds of parts or hundreds of solutions, we can simply create a few simple rules that can capture those possibilities. It's also easier to manage as well, because we only have to adjust our logic here. It utilizes less of our computer resources as well. So less strain on our data management systems if we're using vaults, or we're using less local machine space as well. And there's less processing involved when we're having to regenerate this, because we're simply changing directly the parameters. The other advantage of iLogic is that by adding simple rules, we can increase this complexity. Okay, we don't have to make complicated rules. That seems to be a common misconception amongst people who shy away from iLogic altogether. They think you need to have a strong coding background. That's not the case. As long as you understand logic, you can simply create small, simple rules and then add them one by one. And by adding simple rules, you can create this complexity if you wish. It's quite easy to add rules, and it's quite easy to also suppress these rules. So this makes the whole iLogic part quite flexible, and it's also portable. So without much further ado, we're just going to have a look at this particular data set that I've just developed here. Okay. So what we're going to look at here is a simple scenario where we have a lifting claw here. Okay, so this is it's lifting up, and we want to have a few different configurations for this. For the sakes of simplicity, I've just given a small, medium, and a large scenario for each of these. Now, all I want to be able to do here is change two particular parts. Now, these parts are actually they're low level. They're actually nested right down in amongst some existing sub-assemblies. Okay, so and also what I want to do is actually control the change from a simple drop-down that says small, medium, and large at the very top level, without having to dig too deep down the tree in my assembly. Okay, so this is a bit of a picture of what's going to happen. So when we adjust this, I'm only affecting two parts. Now, it's just to show the concept here. Obviously, you can, and I do encourage you to, once you obtain the data set off me, to take this further and see what else you can drive. Okay. So the task steps I've put together here, just looking at three simple parameters. Okay. So the first step here is we have to investigate our existing design. So initially we would come up with an assembly, and after you've done that, we're going to dig a little deeper and see, well, which particular parts need to manipulate. In this case, I've identified the arm length of the claw and a supporting pole length as well that need to increase in step, so that 10 increment between according to that small, medium, and large flag that I'm going to create. And I also want to think about and decide upon the assembly level parameter that I want to drive changes with. So in my case here, the assembly level parameter I want is just a simple text option that I'm just calling claw size. So in between, as I change the claw size, I want my iLogic to capture those cases and provide me with the change. So when you're first planning iLogic, you have to investigate your design. After you've investigated this design, we then define this into a logic table. Okay, I really encourage you to do this, to actually specify each of those changes into a bit of a spreadsheet, or even just if you want to write it down. Some of you may have heard of tautology tables. This is a programming step that allows you to cover every exhaustive possibility so that you can cover all scenarios. That makes your code robust, and it allows for, I guess, if any, if you do have any situations which are not covered, that are out of bounds, then you can capture or you can actually have your iLogic provide a message box. Okay, so that's what I've actually done. Is any other case outside of what I've provided, I'm going to have a message box actually explain that we haven't got that functionality yet. Okay, so make sure you do create your own logic table, and then you do all this prior to actually creating the code. All right, next is to then rename those parameters. Firstly, in the dependents themselves, so starting from the bottom, changing the names of those parameters if they exist, and then all the way up to the assembly level, we want to then change the assembly level or the driving parameter so that all of this can be achievable. Finally, the last step is to implement the rule as per our logic table. Create a form that can simply allow us to drive everything from just a simple parameter rather than going into our parameters list. This can remove a lot of complexity and also gives the end user a very simple interface to work with. And then you just test and debug. So you should test it, all scenarios, debug it. This is called white box testing and black box testing. So allows you to test every single, provide some test cases. You might try the existing cases and then cases when you choose something out of bounds. Okay, this will increase the robustness of your code. Okay, so that's the task at hand here. All right. So without further ado, we're going to go to Inventor now. I'll just grab it now here. All right. So first of all, I want to investigate my design here. So the parameters I'm looking for, well, the objects that I'm looking for, making sure I'm in part priority here, is this arm. Okay, this part. I want the length to extend, and I want this pole length to extend as well. So this is the arm length, this is the pole length. So let's just investigate these parts and see what parameters are actually being used here. Okay, so if I find my extrusion here, I can see the dimensions. All right. So here I've got an overall length, and I can see that the name of that parameter is not renamed. So I'm going to now just rename this to arm length. Okay. And if you need to, you can just change the dimension display here, so we can actually see those expressions as we type them in. Okay, so arm length is going to be some value. All right. So now I'll just return back, and next I'm going to create a parameter in here, or rename it parameter here for the pole length. So if I just edit this one, just show the parameters, or show the dimensions of this particular hole here, I can see here that there's an overall length is 70. D1. Okay, so I'm going to call this one pole length equals. Okay, just keep in mind when you're doing parameters, renaming them, make sure that you don't put spaces within the variable name. That's not allowed. You could put underscores in between. I prefer what's called camel case, which you just start each capital letter with, start each word with a new capital letter. That's how a lot of programmers create their variables. So, and there's no all this white space in between the equal sign. It doesn't matter. Okay, it's not going to affect anything. So just keep that in mind. You cannot have spaces within your actual parameter. Okay, so just accept that. And if you need to, we can just show the expression there. And you can see their poll length is 70 at the moment. Okay, cool. So let's just return. All right. And now we can go to our assembly level parameters. Okay, so if you go to parameters here, it's also in your Manage tab or in your Quick Access toolbar. And what I want to do is I want to create a user parameter here. I want to create a little, as I mentioned, a text field. Okay, so remember I've got my iLogic table here. As I change my text, okay, it's going to then make these changes in my iLogic. Okay, so we're going to call this one clause size and give it 3 inputs: small, medium, and large, just some text. Okay, so in this drop down, I'm going to add a text variable. I'm going to call that clause size. Now, you can create multi-value lists. If you just right-click on that clause size there, I can make this a multi-value list. Okay, and in here, I can specify each value on a new line. So all I have to do here, I'll just keep it more simple. I'm going to put small, medium, and large. And then I can add all of those here. Now, if I don't want to allow for custom values, then I'd leave this unchecked. But if I do allow custom values here, and obviously a text value is not going to be any help, but if I had, say, an integer or I guess a number value that is driving this change, then I can actually capture those in fuzzy logic in my iLogic coding. Okay, so at the moment I just want to have that switched off. Okay, I'm going to accept that. So at the moment I've got this small, medium, and large setting, and currently that's not making any impact to my design. Okay. It's always a good idea to, as you rename these, you can actually put some comments to say that this is the iLogic driving parameter. Okay, just allows the next person to see that is the case. So I just lost that. Okay, cool. So far we've just identified each of those parameters, and we've also created a driving parameter at the very top level. And as you can see in my browser over here, these components are quite low level, all right? So I'm able to access the parameters straight down the tree without having to go through any complex loops. iLogic allows me to directly change parameters all the way down with immediacy and just being direct with it. Okay, so what we're going to do is just see that, okay, as this moves up and down, this is working fine. So I need to just create an iLogic rule. Okay, so over here in the Manage tab, we have the iLogic browser. and this pops up on the right hand side if you haven't already anchored it. Okay, so it might pop up like this. I'm just going to place it and anchor it to the right of my screen. Alright, so we're really just looking at rules here initially. So let's just click on rules. You can create the rule up here, or you can right click on the assembly itself and add a rule. Okay. Alright, so let's give this rule a name. So I'm going to call this extend arms, claw arms. Okay, so this is when I run this rule, I want this to extend the claw arms and anything that moves with it. Okay, so let's just accept that. And initially, you should just go OK and have nothing in it, just so that you can ensure that you have that rule there. It saves it. Okay. Now, with these rules, you can always just suppress the rule and it switches it off. So you don't always have to have this running. I can switch that back on by unsuppressing it. So this is one of those flexibilities that I was mentioning about the iLogic rules. They're quite powerful here. All right. So next, I'm going to just right-click and edit that rule. So I'll go back into the iLogic browser. The iLogic IDE. Okay. So this is the integrated development environment. Okay. So those of you who have never seen iLogic before, you have a number of coding snippets. Okay. And some you can save as your custom snippets in here. Okay. So as you can see, just looking at some of these custom ones, you've got integration with Microsoft Excel if you want to export to a CSV file, or there is actually over here on the default ones, you've got Excel data links. Okay, so I had to make an amendment here just due to lack of time today, but I will include that in the updated version of this data set for those of you who want to get that. But outside of that, we've got all our parameters, and you can see as you highlight each of these options, we can certainly edit parameters or get parameters, set parameters, okay? And each of these, in the tooltip at the top, the bold text just explains what each of these settings do. So all I need to do to grab one of these options or these snippets of code is if I just double click it, it will position wherever my cursor has been in my list. So I can just bring those snippets in, and you can see it automatically types most of the code there, and you can just simply go in and change some of the values as you see fit. Okay, so this can really speed things up when it comes to coding. You don't have to know how to code as such. The syntax comes in and can save you a lot of time. For those of you who are wondering what iLogic, where it's come from, what it's derived from, it's actually using VB.NET. Okay, so it's anyone who's familiar with VB will be familiar with the iLogic interface. So those who are moving to advanced, you can actually use iLogic as well, just to import other libraries. Okay, so you can actually, if you have any other .NET libraries that you want to pipe to, then you can certainly do that. All right, so let's start to create our iLogic here. So what we wanted to do is create what's called a select case. Okay, so we could actually do an if then end if. So if expression, then then do something. Okay, that's how this reads. Um, else if you may have another condition and it does something else. Else is to capture all other options. Now, if we were to do this particular iLogic table, I would have to, the way this would read would be if the clause size is reading small, then I want this parts parameter. This one will be arm length. I want it to be 170. I want the pole length to be 70 for this part. Okay, so that's the logic there, and that's how it reads. Now, I would, if I use the if then and if, I would have to create 3 separate ones. So if small and create, then make this parameter 170 and this parameter 70. That would be how this reads. Now, I don't want to do it that way. I want to actually combine everything into another way, into a select case. Okay, so this is down on this drop down. This has the framework for the select case options. So I can use the select case to select a variable, and for each case, small, medium, and large, it does some things, it captures some things, and if any case else will default to my message box. Okay, so let's just create this. So I'm going to select case. All right, and I just like to give it a bit of spacing as we do it. Now at the case here, I want my driving rule to be the user parameter that I created, clause size. So you can see here I've gone to my iLogic, grabbed the user parameters, and I can see clause sizes right there with a value. So if I just double click on that, it will come in here. Okay, so the way this works is it will grab this clause size, and for each case, so case, let's start with the first one, case where it's small. Okay, I might have to actually just indent that. So it's always good to make sure that your code is readable as well. When you're dealing with text, they have to be inside some quotation marks. Okay, so this is just because this is a string data type, okay, or text type. All right, so underneath case, when it's small, I'm going to do something. So if I just, for now, just say something. Okay, so you can see there I've just used a leading apostrophe there, and that is how we comment in our text, in our code. Okay, so this doesn't run anything. This is just notes that you can put into your code, and I'd encourage you to always author your code and also document it as you go. So I'd say something like that, and a timestamp and when it was revised. Okay. All right. So next, I'll just put all the rest of the structure in first. So I'm going to place case where it's medium. And after this, you can actually start to copy and paste some things. So I'm going to copy, copy, paste. Okay. Medium. Something when it's LG, large. All right, I also want to have a case for when it doesn't for all other cases, all right? So just in case someone changes that multi-value list include custom values, in case at least my code can capture any errors that may creep through. So this is just error handling. Okay, so I'm going to add case else, and then I'm going to put in a let's just say error, just to remind me that this is for any error that takes place. And then finally, I have to close the structure, so that'll be end select. All right, cool. So the first item is we're going to capture the parameter of our, and I've just written this down. This is the part here is that claw arm, and that's actually my part 10505. Okay, so I want to change a parameter in there. So if you have a look underneath the parameters, we can actually find parameter within. Okay, we can find a parameter within an assembly. Okay, and this is the one I want you to be using here. So all I need to do here is double click it while my cursor is sitting in the place I want it. And I just double click it. Now I'm going to have one part here. This part I just have to copy and paste the value. So it's a bit of a long variable name here. One part number. Okay, so this is just the 505 part, the claw arm, and the parameter D0. I actually want to change that to read arm length. Okay, so let's make sure that we put in arm length. Now, if you didn't want to type it in like this, you can obviously find it in here. If you want to find the part that you're after, so it was 505, it would be in there, and I'll be able to extract the that information. So I think it's actually sitting under one of these nested. There's 1.6, but you can see there I've got that pole length in the next one. Okay, so that's my next one. I'm going to place as well, but I'll do that next time around. So let's just set this for the small setting we've got in our table. Okay, so for the arm length, this was 170 for the small, 180 for the medium, and 190 for the large. So let's just place that in 170. Okay, I'm going to copy that and paste it in each one, just changing it to explicit values there. Alright, so far we've got it moving the arm here. Alright, so let's just accept that. Go OK. When it compiles, it will actually save it like this. Okay, otherwise you'll get a pop-up which tells you if there is an error. So let's just simulate errors quickly. Just take this out and then click OK. You'll get a compilation error here, and it'll just tell you which line of the code the error lies. So line 16, you can see here down the bottom right hand corner of my my IDE here, I've got line 16 here highlighted. Okay, so something else I need that select rather than type it. Select, end select, sorry. Alright, cool, let's just accept that and see what happens. So now if I just change that parameter from small to medium, click done. Okay, something may not have changed there. So let's just have a look. Okay, so you can see there it is actually driving the change in my model. Alright, but the poles aren't shifting either. Okay, so I need to make sure that this compensates for that change. Alright, So let me just edit this and make the change for my next component. So I'm just going to copy that, paste it here, and the next component was 1.6 for my pole length here. And that was basically going from 70 up to 90. So I'm just copying this. A good way to use these comments, by the way, if you want, is you can actually put them after, say, pole length. This can just give you a bit of information about what's taking place here. Always document, okay, because this can get, as I said, as you add more complexity, it will become harder to read. So simple rules would be ideal here, with plenty of comments. Alright, I do need error catcher just in case someone does change this, so I'm just going to use the message box, which is, show a message box. So, and the message I want, just going to paste this in, save some time. Okay, cool, let me just put that back there. Alright, cool. Another thing you should also keep in mind is the column width here. You should really aim to keep it about 80 characters wide. You can include a carriage return. It's the same as in VB.NET, but I'll just leave that as is for now. Alright, cool, so that is pretty much my code there. If I go OK, it should compile well, and let's just drive that change again. Okay. Right, so you can see there the pole arms are also changing with that. Now, let's simplify a lot of this. Let's use a form. Instead of having to go up into my parameters, I actually want to create a new form. So if you right-click in here, you can add a new form. What happens is you end up with this interface here. This is our form editor, and I might call this for configure. So that'll be the name of my form. Okay, and along the side you can actually click and drag different items. So I might want to actually show a picture of what exactly is happening first, and then the variable it's going to change. So let's put the picture in there. I'll put an image. Now here I've got one that I've saved earlier. Okay, and I might also click and drag the user parameter here to drive my model. Okay, so let's pop it there as well. So this is how a preview of how the window is going to look. And then you can go OK. So now I have a rule and I have a form that can drive this. Just also, I'm going to go back to my rule and just change some colors as well, just so that you can see visually the appearance will change, just so that I know if it's a small, a medium, or a large. So let's just edit that rule again. I'm going to add one more under here. I'm going to change some component colors, just so you can see that the arm is actually going to change. So just to save time, I'm going to paste it in here, but you can basically change the component color here. Okay, so I'm going to instead just paste this in. So that's going to come in yellow. Just some nice simple colors. Whoops. This one's going to be red. And this is going to be blue. Alright, so now all I have to do is drive my form. Okay, so let's just change our view. So you can see here, all I need to do is change it from large, which is blue, medium, red, small, which is yellow. Now you can see how quick that is, and anytime I don't want to actually have any changes, I can just disable the rule. Alright, so iLogic is so much faster than actually having to create an iAssembly each time. We can go one step further, and this is something I'll have to update for those who want it, but we can actually, if you want to have different departments driving the model from a spreadsheet, you may have some engineers putting in some values, you can certainly have those inputs from Excel drive straight into iLogic as well. Alright, well hopefully there are some questions at the end of this, and what I'd like to do is just provide my email address again. It'll be just typing it into the chat. Okay, so any questions or any requests for the data set here, you're more than welcome to just send me an email, and I can provide that as well. If you'd like to see some of the taking it further into Microsoft Excel, so that you could at least have different departments driving those changes, if it fits your workflow and in your organization, then by all means just let me know, and we can certainly open that discussion. Okay, so I'll be just online fielding any, I guess, questions in the chat, or otherwise send it to my email that I've provided. Okay. All right. So thanks a lot, and I hope you enjoyed that webinar. Okay. Cheers.